Hello everybody, so welcome back to our channel. In this video, we are going to solve a combined conduction convection heat transfer. A cylindrical rod with a diameter of 10 cm and a length of 50 cm is exposed to a fluid at a temperature of 80 degree Kelvin. The rod is made of a material with a thermal conductivity of 25 watts per meter Kelvin and a convective heat transfer coefficient of 100 watts per squared meter Kelvin. The surrounding fluid has a temperature of 20 degrees Kelvin, and the convection occurs with a constant heat transfer coefficient. Assuming steady state conditions and neglecting radiation effects, calculate the heat transfer rate from the rod to the surrounding. So before we are going to proceed in solving the problem, we will identify first our given. So we have here 10 cm as the diameter, which is 0.10 in meter. Also, we have here 50 cm as 0.50 in meter. We have the temperature of the rod, which is equal to 80 degree Kelvin, the temperature of the fluid, which is equal to 20 degree Kelvin. Also, we have here 25 watts per meter Kelvin, which is the thermal conductivity. Also, we have here 100 watts per square meter Kelvin, which is the heat transfer coefficient. So the problem says that we will find the heat transfer rate from the rod to the surrounding fluid. To solve this problem, we'll need to consider both convection and conduction heat transfer mechanisms. So the total heat transfer rate can be expressed as the sum of the convection and conduction heat transfer rates. So we have here the equation. So we have here the equation for the heat transfer rate of convection, which is equal to the convection heat transfer coefficient multiplied by the surface area multiplied by the change in temperature. So we have now the H multiplied by the area of the rod, pi dl, then the change of temperature, which is equal to the temperature of rod minus the temperature of the fluid. So plugging the values in this equation, we will have 1000 watts per square meter Kelvin multiplied by pi 0.1 meter multiplied by 0.5 meter multiplied by the change in temperature, which is 60. So plugging these values in the calculator, we will now have the heat transfer rate of convection, which is equal to 942.5 watts. So let's proceed in finding the heat transfer rate for conduction. So we have here the equation for conduction, which is equal to K multiplied with surface area multiplied with the quantity of the change in time over the length. So we have now the thermal conductivity, which is denoted by K, multiplied by the surface area, which is equal to the pi d over 2 raised to 2 multiplied by the change in time over length. So we will now have this given. Let's plug this given in this equation. So we will have 25 watts per meter Kelvin multiplied by pi 0.1 meter over 2 raised to 2 multiplied by the change in temperature, which is equal to 60 degree Kelvin over the length 0.50 meter. So plugging these values in the calculator, we will have the rate of heat transfer through conduction, which is equal to 23.55 watts. So going back in this equation, we can now solve our total heat transfer rate from the rod to the surrounding fluid. So we have the heat transfer or the total heat transfer rate, which is equal to 942.5 watts plus 23.55 watts. So plugging these values in calculator, we will now have the total heat transfer rate, which is equal to 966.05 watts.